So let's take a look at how we can transition from a state transition graph, or do the translation rather, from a state transition graph to code. Specifically, we're going to capture the structure of the solution in the form of code, and we call it in code, we call it a data structure. The structure of our solution, or the FSM, is captured in the form of a data structure. So let's see how that's done. So first thing I'm going to do is I will make a note of the fact that I have this solution which has two states. There are two inputs. The green input is a 0, red input is a 1. It produces two different outputs, a 0 and a 1, which are colored here as magenta and cyan. So first let's describe our state. A state for us, so I'm going to say struct state. A state for us then is going to have these attributes. The first attribute is going to be an unsigned, and every state has an output. So I'm going to call that an unsigned car out, because there's a one-to-one correspondence between the state and output. The second field of interest to us, so states don't have inputs, states react to inputs. So we'll get to the inputs in just a second. One of the things we're going to do in our problem is because we are reading, and so let's go back to the system description. Because we're reading inputs and we're producing outputs, and the inputs are coming as a sequence, if you will, of 0, 1, 1, 0, 0, 0, 1, 1, and so on. What we're going to do is we will specify that the time delay between bits, we will make sure that when we read these inputs, because they're going to be coming from a switch that I press when I do the implementation, I expect that the time delay between reading inputs is going to be some set of pre-specified value, let's say half a second or 0.1 seconds, doesn't matter. So we will have some wait between reading inputs, and we'll see why that wait is going to be used. So for now, I'm going to specify another attribute for each state, which means when I'm in any given state, I'm going to wait for that long, and I'm going to call this an unsigned long wait. We'll see the use of it when we get to our code that we complete. The third field of interest, attribute of interest, is important. And the third attribute of interest is, what is my next state? For every state, there is a next state. That is, it's possible that on an input of 0, I stay here. On an input of 1, I go there. So how many possible next states does this state even have? Well, it depends on how many inputs it has to process. So because there are two inputs I have to process, that is a possibility of 0. On an input of 0, I stay here. On an input of 1, I go there. So this array here is telling what are all the next states I can reach from this particular state. So it's going to be an array of 2 next states. And this then is going to be a unsigned. I have an array of next states, which I'm calling unsigned car. And the idea will be that what I'll store here is might write a comment here. This will be the index of the state. So in other words, if I want to say that on an input of 0, I go to the even state, even state is going to be given an index, and odd is going to be given an index. So the way I do that is before I do that is I define even to be an index of 0, and I define odd to be an index of 1. So I'm numbering the states. This is because there are only 2 states, I'm going to call this a 0 state and a 1 state. And like we did before, I'm going to define a type def struct state to be an S type. I've captured the structure, but I also have to capture the content. So my continuation of this, I'm going to write it here. So I have an array called FSM of size 2. That's because there are 2 states in my system. And these 2 states, I'm going to populate the 2 states, which in this case, this is how I declare and initialize an array. Remember, we already know this. So I put a curly braces. The first element is going to be a structure. The second element is also a structure, and I close it. So what is the first element of my array? Well, each element is of type S type, and we know that the first element has 3 attributes. The first attribute is the output, and I know that in this case I'm going to produce an output. So this will be my state even, and this will be my state odd. So let's make that and make a note of that. So this will be my state even, and this will be my state odd. So with respect to even, the output I will produce is going to be a 0. With respect to even, so the output is a 0. And what I also know is, since we have a wait of certain time, I'm just going to for now give a number here. I'll put a number 100, and we'll see how this gets used. And my third attribute for my state is an array. So remember, arrays are always initialized using curly braces. So what this is saying is, on an input of 0, I stay in even. So I'm going to write here, I'm going to make a note, which is that I stay in even. And on an input of 1, I go to odd. So that's my odd. Similarly, for my second state, my output is a 1, and the delay is also 100 because I'm going to use the same delay between state transitions. And my array here is saying that on an input of 0, I stay in odd. So I say odd. On input of 1, I go to even. So this will initialize the array, and in fact, we will look at how this looks in memory in just a second. But first, let's also clarify something else, which is that on this array is indexed by, so on a 0, it says that I stay here, and on a 1, which is this value here, I go there. So let's now visualize this as it would appear in memory. So I'm going to do it right here. I'm going to erase this part here and see what gets created in memory, what gets stored in memory as a result of this declaration. So there's going to be, this is my FSM of 0, and this is my FSM 1, which, by the way, this is my even structure and this is my odd structure. And what I see here is a value of 0 and a value of 100. This is one character. This is a long, so it's going to be 4 bytes. And then I have an array of 2 locations, which are both character. And the first one will have a value which is even, which in this case I'm going to first write it. I'm going to call this even, which has been defined as a synonym for 0, and an odd, which is the synonym for 1. And the second array then is going to have a input of 1, the output of 1, and a delay of 100, and 2 elements here, which is odd, and in memory that's going to be a number which is 1, and an even, which is a number which is 0. And this is my next state array of 0. This is next of 1 as a field within FSM1, and this is my out, this is my wait. Similarly, this is my out, wait, and this is my next. So these are all, there's a dot, if you will, if I want to access it. This is next of 0, and this is next of 1. And this, in fact, is my index here. This is the green indexes, and these are my red indexes, which tell me on what input that happens.